know what I'm talking about, but I will show you later on in several cases I will present here. So for the furniture I made by hand, I was always looking for some organic stuff, comparison to Gallet, Victor Horta from Belgium, architect, all in the Army Wall area around 1900, so that was my favorite type of furniture. So I came up with Batoidea, that's a Latin name for stingray fish, and actually this was a contest for T-splines, the use of T-splines in extreme. So I did a contest in Salt Lake City with Matthew Sederberg and stuff like that, and I got the second place. I don't mind getting the first place or getting the second place. The comments were it was a very nice chair, but it wasn't possible to make. So that's what we do in Belgium. We just make it. We don't talk about it. We do it. So I went to Voxeljet in Germany. They got these huge sand printers. They can print sand molds about cubic meters and bigger. So it's the same principle. They just spread the sand, they glue it together, and where there was no glue, they blow away the loose sand. So it's very, very simple. So for this case, the chair was designed in Rhino using T-splines, so you get a CAD model, not a mesh model, but a CAD model. For the sand printing, you also need a CAD model. So in Rhino, you can split up the molds, and you send them over as an step file or an IGES file, and they just print it. You get it back by truck, and you mix it, put it together. You put some casting channels on it, and you can cast it. So actually, it's a little bit more complex than as I explained, but it actually is quite simple. So after a few weeks, I sent back these images to the jury for the contest, and that's how we do it in Belgium. And they sent another reminder from, oh, okay, you're able to do this stuff, you can do other stuff. So that's my son then in the chair. So it's a real one. This is a render, and this is the real product. So it's the same. That's what our friends told before. You can design something, you can show it, and you can make it identically as you show it. So then Materialize is one of the biggest 3D printing companies in the world. It started in Belgium 25 years ago, so they had a meeting in 2015 for the 25th anniversary, and there was an exhibition making the difference in making. So I designed this chair, the T-joint. The basic principle of the T-joint was also a cast frame, but I thought it was too big to print, too big to cast, so I figured out another way to make a combination of tubes and 3D printed parts. In this case it would be titanium, so all the joints are designed in Rhino and sent over to a metal printer, and they came back polished, and it's manual polished. And then we could put the chair together. Also, I'm not strict to materials or techniques. I try to use everything. I make a mix match from everything. So I worked, for example, with Anne van Hooy. She's a famous ceramist in Belgium. So I design, sometimes I make 3D designs for her. The molds are printed positive. We make a silicon mold, then we make a plaster mold, so we can pour in the clay for reproduction. The balls on the right side are a project with disabled people, so it's a combination of several companies. First of all, the design was done by the two of us, then Materialize was printing the mold, the positive mold. The company with the disabled people, they make ceramics on a low scale, low budget, and they were able to keep the people busy they got a job, they got a real product, they were proud of making this product. So, and then there came in a big company, Xerox in Belgium. They distributed, they looked for the distribution of the product. So these molds are now going global. So that's also very interesting what you can do with just the way how you use 3D printing. If you need a mold, you can print it. If you need another size, you can scale it. It's very fast, very easy. So this is one of an evolvement of the little balls. So we can scale it, we can manipulate the structure. And this one was made in Taiwan, I guess, together with this example of little coffee cups, teacups, water cups, whatever. Very thin porcelain, yeah, ceramic, and it's translucent, so thin it is. So the pattern is made with grasshopper, and I will show you later because I use the same patterns on different designs, so you can do a lot of funny stuff. Also, T-spline's chair on the bottom, it's a render. On top, these are the cast parts, also from 3D print. And then we polish it and we assemble it, welding. So it's always a combination of digital and handmade. You cannot expect a printer to print a shiny piece like that. It's impossible. So a lot of people don't know. Most of the people, they think it comes out of the printer and you can buy it, you can sell it. No way, it's always a lot of labor. So what I do with furniture, I can do in jewelry. It's all, actually it's all the same, because when I design a chair, you can sit on it, but if you make the chair small enough, you can wear it around your arm or your neck, or you can make it bigger, you can live in it. So it's a chair to sit in, a chair to live in, a chair to wear around your neck. It's a size. So this is the way I work. I try to go back to the basic structure. The exceptional high dense mesh at the end is parametric, so I can manipulate that. So in this case, the frog, I guess this is the right one, yeah. So I start with this is a mesh, very basic mesh. It's a T-splines, it's 400 polygons. And then you can see, you can subdivide it, it gets smooth. So that's very simple. And then you can add a structure on it and a thickness. So this is the thickness and the structure, and then I can adjust the structure. And the thickness is also, it's 0.98 millimeters for printing. And then if I subdivide the base model, the structure goes up. See? And by hand, this is impossible to make in wax. This is way too complex. So I start with 400 polygons and I end up with 600,000 polygons. And everything is adjustable because in a moment you will see when I change the base model, I can let them talk, I can let them move, and it's all the same. It's all, and everything will follow the steps behind. So this is the T-splines. So you could make thousands of different frog rings doing funny stuff. I kept it with just two, but it's possible. then one nice thing about this, with the Grasshopper, you get a very tight STL file. There are no edges, so it's fun to print. You just put it in and they print it. It's no problem. Let's undo. Yeah, undo. So that's for the jewelry. For the frog. Yeah. So this is the actually the end product. And if you imagine it, it's only this big and it's very detailed. You can look with the how you call it in the magnifying glass, and you see all the details. And so I keep it short. I can go back to the first one. The first slide was a egg cup. It's also printed ceramics. So this was not possible to make in a traditional plaster mold because the mold would break and the product would break. So using the different materials for the different designs, you can do almost whatever you like in 3D printing. Okay. Any questions or? Yeah?
Loud. How would you compare 400 polygon with ZBrush?
Excuse me?
You know ZBrush? How would you compare ZBrush with the 400 polygon?
The brush?
Software.
No, software is the frog from 300 polygons was done with T-splines. ZBrush, you got different. I didn't compare with ZBrush.
How much does this one cost per polygon?
At the end?
Yeah.
600,000.
600,000?
Yeah.
Thank you.
No, not the cost. You.
I mean the cost for the software.
The cost of the software,
yes,
is free.
Can I get it free from the internet?
Yeah, the Grasshopper is free.
How can I get the money?
And then you got Rhino, it's about $1,000.
Thanks.
So it's not so expensive.
Hi, I wonder the chair you made for your son, or what your son was sitting on, is it cast iron or aluminum?
Cast aluminum.
Cast aluminum.
But it's no problem what you pour in. You can do bronze, or you can. I did this one. This one is titanium. It's printed, and this one is bronze. So it's polished.
But casting is
it's all
cheaper than well, printed titanium. Yeah.
Yeah, printed titanium. When you get small pieces, it's interesting. If it's getting bigger, it's very expensive. Also, the titanium is limited by 25, 20 something. If you have to print a chair in titanium and put it together, you cannot. Yeah, you can weld it, but normally at the materialized aluminum prints, they glue together with special glue. So you can print the chair in pieces and glue it together. I don't know. I see when you look with the microscope on 3D printed titanium, it's a landscape. It's not smooth. It's not nice. So then it has to be finished. There's a lot of work after the printing. Also, our friend he told about there's one gold printer over here in China. It's I think it's a platform this size. It's 1 kilo of gold powder. It's $30,000 powder. So if you blow, you lose. And the product is not shiny what comes out. And printing gold is 3 times the price of printing wax and casting it in gold. So, for example, a ring like the frog ring, I get it printed and cast in silver and polished at my home. I don't move from my chair. I just push the button and I pay for something like $30 US dollars, $30, $40 in silver. If you have to print it in gold, it would cost you $1,500 printing in gold. If you cast it, it would cost you $500 in gold.
Is there a size limitation for cast aluminum or aluminium?
Yeah, cast aluminum is the size limit is the mold limit. In this case, the mold limit is the printer size limit. So this is a very big printer. It's over 2 meters.
How about the height?
80, 90 centimeters. Cubic meters. Oh, the chair, this was 130 by, it's almost 1 cubic meter. If you see the sand print, would cost 4,000 to 5,000 US dollars per cubic meter. That's very cheap for a big object. If you print the chair in plastic, it would cost you 10,000. You have the plastic chair. You have to make the mold around. Now you got the mold. So the sand mold is gives you the freedom to make undercuts and stuff like that. So you print the stuff you cannot make with the CNC machine. You can print in sand. I came across the sand printer. I saw a movie from Ferrari. They were using the sand molds for testing their engines before they moved to the steel molds. So they perfect first with sand molds, and then they make for the production.
And the mold cannot be reused?
They working on, because this is with undercuts, yeah? So you tear apart the mold when it's a sand mold like the traditional sand casting. But they're working on materials when you got the efficient angles on the mold. You can print like some kind of concrete and you can use it up to 100 times. For a small series, it's possible to print the mold also. And the accuracy is very nice, it's very good. No lines, no nothing, it's smooth. It's a German company, Voxeljet. So there's a lot of potential in big size printing, casting. And it's quite affordable. All these pieces are very expensive to make, but in a production environment it would not be possible. The molds would be extremely expensive.
So you have to go there to see what they do. So you can't just send them a file.
Yeah,
you have to go there and watch. Yeah, otherwise they're gonna screw it up.
No, they don't screw it up. They just. I heard about the company. I sent them an email. Can you print this? I sent them the files. Yes, that's the price. And they say, okay, print. And I got it 3 weeks later. They sent the sand. So there's no problem. I don't have to go there. I trust people, and if they deliver, I pay. So. But it's very interesting. I think for semi-production, rapid prototyping, you could do very, very nice productions before investing the big money, and you got a really nice object. So it's not limited to furniture. You can do parts of cars, you can parts of anything cast. Very complex shapes. Just print it in sand and you cast it. So it's a balance for what would you like. If your part fits in the metal printer, you could print it in metal. If it's too expensive, you could go to the sand mold and make a small series. You can combine many pieces in one mold and you fill it up. And you can use the one part of the mold to be the next part for the next, so you can build it up. But that's engineering, so there are a lot of possibilities. Also for the jewelry, it's not printed gold. It's printed in wax and cast and polished by hand. It's somewhere in Russia, or I don't know who does it, but it's quite expensive. Also, if you see what in China the regular prices are for a ring, it's quite expensive printing stuff, but you can personalize everything. You can put your name on it, and I think for the medical sector it will be much faster improvement for 3D printing than in the household and in the, because everybody is different. You can make an MRI scan, you can bring a part. If your arm is missing, you can scan this one, you flip it over and you make a new one. That's how they do it.
Any more questions to Peter? Feel free to ask.
Yeah, feel free. I'm here.
Peter, I have a question for you. I'm actually quite, I've never been to Belgium, and I'm very interested in the Belgian market. So in Belgium, do you think in the 3D printing industry, do you have more of the designer strong in design or strong in technical, like mechanical machine stuff, you would say?
In Belgium, there's it's a different than here, because our colleagues are talking about design, making content for the machines, and it's correct. We have to make content. Everybody has to make content. But in Belgium, we got Materialize, and they are way advanced company for 25 years doing 3D printing. So everything is possible in Belgium. If you need a part, you can hire a designer on their website. You can just say, can you make me this part? There's a shop, everything is available. Also in Holland, you got Shapeways. It's from the other university. So Materialize comes from the University from Leuven, spin-off, and Shapeway comes from Eindhoven. It's a different country. And actually, it's the same, almost the same period. Also, one of the patents was filed by the Belgian guy from Materialize for, I think, slicing off or something, I don't know. But it's expired, so it's 25 years old. But engineering, there's a combination in Belgium. There's arty-farty stuff and stuff you can use. It's not that the arty-farty stuff you cannot use, but actually there's no need to do a lot of stuff like that. So what I was saying with the engineering, at Materialize, they got 1,000 or 1,200 people working there. The biggest part is developing software for medical sector. They don't show it to the outside world, but that's the main business they do. So they're printing kidneys, and they will last an hour now. Real live kidneys. So that's something to think about. It's getting very technical at that end, if that's what you mean. Engineering for machine parts, car industry, they do it all. They do it all. They got these mammoth printers with liquids. They are 2 meters 20 by 1 meter by 80. So that's the biggest liquid printer in the world, and it's also 20 years old now. It's still working. They got a whole bunch of those machines. So they can build they can print a real body, full-size body. But it's also expensive. It's time, it's layers, it's always size, time, material, gravity, blah, blah, blah.
Okay. Thank you, Peter. Thank you so much for your sharing.